Today we are going to study about motion in a straight line. Okay, so let us take this ball. If I drop this ball is moving down in a straight line, right? So we are going to look at first two very important concepts, then we'll look at velocity and things like that, speed, etc. First, let us understand what is the difference between distance and displacement. Now suppose I take this ball and this ball moves like that. Now this ball has a distance that it has traveled. I will use the symbol d. What is distance? It is the length of this path. So if you measure the length of this path, you will get distance. But we also are going to use another word which is called displacement. Now if you look at the word in the center of displacement, what do you see? Place. Displace. What is place? Position. So this fellow was here. Now this fellow is now come there. I don't care that it went like this. It may have gone like that. So for example, if I went like this, is this distance equal to that distance? No, right? This is d1, this is d2. These distances are different. But the place, it was originally there, it is now finally here. We will say initial, the beginning, final. Displacement means change of place. Displace means change. Change what? Place. So I have changed the place. So from this place to that place, let's draw an arrow. This arrow is displacement. Sometimes people say we use the letters S. Why? Because D was already used for distance. I is used in many places, so we won't use I. So that means the next letter S. So displacement goes and grabs the letter S. So what is S? Displacement. So what is displacement? Displacement is the change in place or change in position. We are going to use the x-axis to talk about position. Where are you? I am at x is equal to 0. I am at x is equal to 2. I am at x is equal to 1. I am at x is equal to 3. I am at x is equal to 2.5. So if I was at, and let's say that was 4. So let us say I started here and this object moved from here to there. My displacement is this arrow from 2.5 to, what is this? Let us say 0.5. So what is my displacement? My displacement is final position 0.5 minus my initial position 2.5 minus 2 meters. Okay, but if I started at, let us say 2 and I moved to 4 like this, that is, I'm moving there, I'm just showing it here. So I start here and I move there, I'm moving like that. What is my displacement? What is the final? 4. What is the initial? 2. So 4 minus 2 plus 2. So this displacement or this displacement is plus 2. This displacement is minus 2. So displacement is final position minus initial position. For to say position, shortcut I am using x. Many times we will use change in position. Change in position. Now this is too long. For position, what am I saying? X. But if I write change in x, it's still too long. So what will I do? I use a symbol for this. We will call this symbol delta and say that this means change in. So what is the meaning of delta x? Change in x. Change in position. What is that? Displacement. So displacement is an arrow. Many times people think displacement is the shortest distance. No. Displacement can be plus or minus. Actually, magnitude of displacement, we write it like that with a bar. What does that mean? If it is minus 2 or plus 2, remove the minus, call it just 2. Now magnitude of displacement is the shortest distance because it's a straight line distance. Distance is the length you have traveled. Displacement is the arrow. So let us try to calculate. If I went 7 meters like this and then I went 3 meters like that in the same direction, what is my displacement? 7 plus 3, 10 meters. What is my distance? 10 meters. Because it's 7 plus 3. But if I said I went 7 meters like this, and then I came back 3 meters like that, I usually will not draw it here because it's not easy to see. So I'll just move it below and draw. So that means you are actually here. 7, 3. What is my displacement? My displacement is this arrow. How much is my displacement? 7 minus 3. How much is my displacement? 4 meters. Because you see, I went 7, then I came back 3. That means I only went how much? 4. So this arrow length is 4. So displacement is 4. But what is my distance? 7 plus 3. So what is my distance? It's still 10. Do you see? 7, 3, 10. But displacement is also 10. 7, 3. Distance is 10. But displacement is 4. What will happen if instead I moved like this? Perpendicular. Let us say I move 4 meters like this. And I move 3 meters like this. So my displacement is this arrow. My distance is, how much is my distance? 7. How much is my displacement? Like this square, you know, if this is perpendicular, S square is 4 square plus 3 square. What is 4 square? 16. 3 square? 9. 16 plus 9? 25. Root of 25? 5. So my displacement is 5 meters in that direction, but my distance travelled is 7 meters. I hope the difference between distance and displacement is clear. Very, very important to think about it. We should apply this to various questions and see. Now this was all easy, but later we will see if I moved 3 meters like this and then I move, let us say 5 meters like that. My displacement is this. What is my distance? 8. But this is not easy to calculate. We will learn how to do that later. Okay, right now we will focus on straight line motion, so it's easy. You are either going forward or you are going backward. Forward 7 plus 3, 10. 7 backwards 3. So 7 minus 3, 4. So that is very important. Keep in mind what is the difference between displacement and distance. Displacement is a change in position. If I start here and I go all over and I come back here, is distance 0? Is distance traveled 0? No, right? But if you look at displacement, that is 0 because you are back where you started. Okay, so displacement turns out to be a very useful concept to keep in mind. We're going to see that all over in physics. Let us now look at what is speed and what is velocity. First, let us look at what is speed. Everybody knows what speed is, right? If you're taking a car or you're taking a bike and you're going, you know that your speedometer tells you 30 meters, kilometers per hour, 50 kilometers per hour. So that is the idea of speed, how fast you are moving. So now let us say that we can also measure it in meters per second. Let us say that an object has a speed of 5 meters per second. Suppose it kept going like this for 4 seconds. How much is the distance it has covered? We say 5 meters per second every second. So 5 meters per second plus 5 meters per second plus 5 meters per second plus 5 meters per second. 5 into 4. So how much is this distance? 20 meters. 5 meters per second into 4 seconds. So that gives me 20 meters. Now, is it necessary that you have to go 5 meters per second in a straight line? No, right? I could have instead gone like this. But I could have always maintained 5 meters per second. Then this distance d will be equal to 5 meters per second into 4 seconds. It's still 20 meters, but it is the distance that is 20 meters, right? So in general, we will write speed. So for speed, I need a symbol. So I will use the symbol SP. There is no real symbol for speed. So we use the symbol SP. So speed into time is the distance. So keep that in mind. So distance is equal to speed into time, right? Now look at this fellow. This fellow went like that. This fellow's displacement is this. Is this displacement bigger or the distance bigger? Which is more? Distance is more, right? So displacement here is less than the distance. Okay. So we don't talk about, we will come back to this idea later, but the basic idea is the fact that you have a speed does not mean the distance is equal to displacement. It is not. Okay. But we are going to now talk about a new concept, a different concept, which is velocity. You probably already learnt about this. But if you take a velocity, we are talking about speed with direction. Okay. So when you say velocity, whenever you throw something, it will have both speed and direction. So I am now saying this is the velocity of 5 meters per second. This object has 5 meters per second in that direction. Now if velocity is constant, it cannot change direction, because if you change direction, it's a different velocity. If you change the size, which is basically instead of 5 you make it 3, it's a different velocity. So both have to remain constant. Here I can have 5 meters per second, 5 meters per second, 5 meters per second. It is moving at 5 meters per second, but look at the direction. Here it is moving like this, here it is moving like this, here it is moving like this. So the velocity is changing. Speed is constant. Suppose I tell you velocity is constant. Another word for constant is uniform. So if I say uniform velocity means constant velocity, constant size, which means constant speed, and constant in direction. So if I tell you that this fellow had constant velocity, let us say for 3 seconds, then displacement is 5 into 3, 15 meters. Okay, so this displacement is 15 meters. In general, displacement is velocity into time. So for velocity we use the symbol V. For speed I am going to use the symbol SP. Sometimes people use V also for speed, but that's not a good idea. Velocity V, speed SP. Okay. So now let us think. Velocity is constant, you will get displacement. But what is the distance? This distance is also equal to 15. So if velocity is constant, speed is constant. Obviously, because you can't change direction or magnitude, both. For example, if I kept moving in a straight line, so let us say I started with 5 meters per second. So I was running very fast, then I become very slow. Let us say 1 meter per second. Am I going in a straight line? Yes. Is this constant direction? Yes. Is it constant velocity? No. Why not? Because speed has changed. If I was moving with 5 meters per second, I go like that and then I do this. But it's still 5 meters per second. Here also it is 5 meters per second. It is constant speed but not constant direction. This is not uniform velocity, this is not uniform velocity. If it is uniform velocity, it has to be a straight line and it has to be constant speed. Constant speed, straight line. Okay, so uniform velocity turns out to be very, very important and useful. We will come back to it later again, many times. Okay, so this is a fundamental idea that we have to keep in mind when we are looking at physics. Everywhere in physics, you will talk about uniform velocity. But let us now look at a case where it is motion like this. It is constant speed but not constant velocity. Can I talk about some sort of velocity here? There is a displacement. You cannot say displacement is velocity into time because velocity is not constant. So then we talk about the idea of average velocity. So let us look at this idea of average velocity, because many cases velocity is not constant. So we write it like this. Velocity with a bar. What is the bar? Average. Average velocity is displacement by time always. Every case, every situation, displacement by time is average velocity. It's a definition of average velocity. Velocity into time is displacement only for uniform velocity. This is true for uniform speed. This is true always. So it's also true there. So if it is uniform velocity, average velocity is uniform velocity. But many cases you will have average velocity. You cannot talk about uniform velocity because velocity was changing. So if this fellow goes around like that, displacement is this. Displacement by the time it took is equal to average velocity. So direction of displacement and direction of average velocity is the same. Okay, let us take an example. Okay, so if I start here and let's say that this guy was moving at 4 meters per second for 2 seconds, and then was moving at, let us say, 3 meters per second for 5 seconds. Okay? Average is not 4 plus 3 by 2. Average is this distance plus that displacement, total displacement. So what is the average displacement? First 4 into 2, 8 meters. 3 into 5, 15 meters. What is my total displacement? 8 plus 15. How much is that? 23. So average velocity is 23 meters because my displacement is that way. Divided by total time, 7 seconds. So it's 23 by 7 meters per second. Okay? Should it always be like this? No. For example, if I start here and let us say I go this much. I start at 4 meters per second and I travel for, let's say, 8 seconds. And then I travel in this direction, let us say 5 meters per second, but I travel only for 2 seconds. So what is my displacement? How much is this displacement? 4 into 8, 32 meters. How much is this displacement? 5 meters per second into 2 seconds, 10 meters. So what is my displacement? What is my displacement? It is 32 minus 10, so that is 22 meters. So what is my average velocity? 22 meters divided by, what is the total time? 8 seconds plus 2 seconds, 10 seconds. So it is 22 by 10, 2.2 meters per second. So I hope that is clear. So you see average velocity, you can find this minus that, you can find this plus that, depends on how you are moving because it's displacement by time. But therefore we want to define something called average speed because I want to know how much distance I have traveled, not how much displacement. So if I look at average speed, so I'm going to define average speed here. Average speed is total distance by the total time. Total distance. What is the total distance? 8 plus 15. How much is the average speed? 23 meters divided by 7 seconds. So 23 meters per second. Isn't this the same as that? Yes, because total distance is 23, total displacement is also 23. But let us look at this. Do you remember this? 32, 10. Displacement was 22. But if I look at average speed, what is the total distance? 32 plus 10, 42. Time is still 10 seconds. So 42 by 10, 4.2 meters per second. Do you see that average speed was bigger than the average velocity in terms of magnitude? So we right now not worried about the plus minus sign. So I'm looking only at the magnitude. So what is the difference? Average velocity is the total displacement by the total time. Average speed is the total distance by the total time. So we need to be able to calculate quantities where we can find average speed and average velocity. We'll just do a couple of questions so you'll get an idea. Now in this question, there is a bus or a truck or whatever you want to call that is moving first with 10 meters per second for 4 seconds, then is moving at 6 meters per second for 3 seconds, and then it decides to come this way suddenly. Okay, that's a big change. And then it comes back, I've drawn it below, 2 meters per second for 3 seconds. We want to find out what is the average speed and the average velocity. So here is the average velocity, this is the average speed. Now let us think. What is this displacement? Always draw a diagram. Right now, of course, I have drawn the diagram. Whenever you read a question, first draw the diagram. Half the problem is over if you draw the correct diagram. So 10 into 4, 40. So that is the displacement this way. 8, so this is 6 into 3, 18. So this is 18 meters. And then if you look at this one, it is in this direction, 2 meters per second into 3, 6 meters. So what is my displacement? How much is my displacement? 40 plus 18 minus 6. 40 plus 18 minus 6 divided by the total time 4 plus 3 plus 3. 4 plus 3 plus 3 is 7 plus 3, 10 seconds. So many meters by so many seconds. Now what is this? This is going to be 12 plus 40 is 52. So this is 52 by 10 or 5.2 meters per second. In this direction. Okay, direction for velocity is important. We are not writing. Usually we need to write with direction. So whenever somebody asks you for average velocity or velocity, you need to say which direction. Okay, right now I'm not going to do it. I'm going to treat it as if it is the magnitude of velocity that is asked. Many times that's how people talk. But in principle, if you want the correct way to think about it, I should be saying magnitude of velocity is 5.2. Okay, I should not be just saying velocity. I should say magnitude of velocity is 5.2 meters per second, average velocity. Okay. Now for speed, of course, we don't have to worry about direction. What is the definition for speed, average speed? Total distance by total time, 40 plus 18 plus 6. So 40 plus 18 plus 6 by 10, same time. Time is still 3 plus 3 plus 4. Remember, here also the time adds up, time doesn't subtract. But here time adds up, but the problem is distances add up. Here you are not sure, you have to check what the value will be from displacement. Now let us see how much is this. This is 24 plus 40. How much is 24 plus 40? 64. 64 by 10 is 6.4 meters per second. No situation will you get average speed being less than average velocity magnitude. It may be more, 5.2, 6.4, this is more, or it may be equal. When will it be equal? If you kept going in a straight line, it will be equal. Now instead of asking you for this entire motion, suppose I had only asked for this much. Then average velocity for 4 plus 3 seconds. Okay, only this. How much is it? 40 plus 18, 58 by 7 meters per second. But if you look at average speed, you will get the same number because there is no turning back. But once it turns back, then distance increases, but displacement is decreasing. Okay, so please keep in mind that this is seconds, that is displacement. Sometimes there is confusion. Okay, so therefore do it carefully. Remember that this is with seconds. Okay, so sometimes it's a good idea to put SEC, but the direct symbol is of course S. Displacement is usually put with an arrow. Okay, now let us look at another question. In this question, there is an object that is moving at 4 meters per second for 2 seconds, then makes a right turn, 90-degree turn, 2 meters per second for 3 seconds. What is this distance? 4 into 2, 8 meters. What is this displacement? 8 meters in this direction. What is this distance? 2 meters per second into 3, 6 meters. What is the displacement here? 6 meters. But what is the overall distance travelled? What is the total distance? 8 plus 6, 14 meters. Divided by the time will give me average speed. What is the total time? 5 seconds. So 14 by 5 meters per second. If you multiply by 2, you get 28 by 10, 2.8 meters per second. Always whenever you have division by 5, it's a good idea to multiply by 2. This will become 10. That will become 2 times 14, 28 by 10, 2.8. Okay. So this is the average speed. What is the average velocity? That is displacement by time. Now you can't say 8 plus 6, not allowed. 8 minus 6, no, because it's not going that way. So what is my displacement? It is this. But you know that if this length was S, S square must be equal to this square plus that square, 8 square plus 6 square. 8 square, 64, 6 square, 36, 64 plus 36 is 100, 100 is 10 square. So S is, magnitude of S is 10 in this direction. So my velocity is 10 meters in this direction divided by the time 5 seconds. So you get 2 meters per second. But then if I did not give you magnitude, so whenever we put bar, it means magnitude. So if I don't do that, that means you have to tell me with the direction. So like this. in this direction. So usually to avoid that, we will just say magnitude of the velocity, average velocity is 2 meters per second. Notice, what is this velocity? 4 meters per second. What is this velocity? 2 meters per second. But what is the average velocity? That's also 2 meters per second. It is, sometimes it's even possible. So instead of going this way, suppose I went like this, average velocity may be even less than all of these velocities. But you can see that, because if I start here and I go like this and I come back, what is my displacement? 0. What is my average velocity? 0. But my average speed not equal to 0, because that is distance divided by time. So we will do a bunch of problems, then you will understand this a little better. The basic idea is you must be able to apply it to different types of situations.